All right, class, welcome back for our problem of the day, week 6 cheat sheet. On page 2, we're looking at the following. Learning target. I can construct a linear exponential function given a graph using the regression feature on the calculator. So let's take a look at our question from the January 2019 Regents this past month, or this past January. The following question is as follows. Sodium iodine 131 used to treat a certain medical condition has a half-life of 1.8 hours. The data table below shows the amount of sodium iodine 131 round to the nearest thousands as the dose fades over time. So what do we do? So here's the things that we want to kind of consider. It's specifically asking us, after 18 hours, what will remain of the sodium iodide? So the very first thing to consider is this. Use the data in the table to create a regression in your stat feature of your calculator. Now remember, we don't need all 700 points. We just need a point in the beginning, and the middle, and in the end. So let's choose this point right here for 1 half-life, for 3 half-lives, and for 5 half-lives. So under list 1, we put 1, 3, and 5. And under list 2, we put the corresponding amounts of sodium iodide. Okay? Once we do that, our goal is to hit stat, slide over to calculate. We're doing a exponential regression. So that's 0. Hit enter. Okay. And so our calculator does the heavy lifting. So we know what we have to do is we have to put the following information in our calculator. All right. I'm going to want you to pause the video for 30 seconds. Put that in the calculator and come on back. Okay, welcome back. Hopefully you've gotten this put in your calculator without a problem. Next thing that you're going to do is you're going to hit second graph on your calculator. And we're going to notice after 18 hours, when x is 18, what's the value of y? Well, here the value of y is 0.00106. Now we're supposed to round to the nearest thousands. So what decimal place is that? Let me think. Well, 1 decimal place would be tens. 2 decimal place would be hundreds. 3 decimal places would be, you got it, thousands. So based on that, what would be the best choice? Choice 1, 2, 3, or 4. By now, I hope you guys can agree that choice number 1 is the closest choice based on our information in the graph or in that table. All right, class, welcome back. Let's consider our next question. This comes from the January 2017 Regents. It says that Tanya is making homemade greeting cards. The data table below shows the amount that she spends in dollars in terms of the number of cards she intends to make. Part A, write a linear function that represents this data. All right, again, guys, we're going to pause the video, take about 10-15 seconds, and put the information in your table, very similar to what I've already done here, and then come on back. All right, guys, welcome back. Hopefully, after you have put it into your table, you've hit stat, your stat button, and you're going to slide over to calculate. Now, we got to kind of think about this. What kind of regression are we doing? Are we doing something that's going to be a straight line or a curved line? And one of the things that we can ask ourselves is, what did we learn about in the question? So we know that Tanya's making homemade greeting cards. We also know that it's asking for a linear function. So that's a big deal because our last problem was a exponential. So let's basically take a look at what our options are. So we're going to press 4 for linear regression. We're going to hit enter. All right, we see our linear regression puts our slope at 0.75 and our y-intercept at 4.5. And then to put that in our calculator as such. And so now we've identified what my slope, we've identified what my my function is going to be. All right. So my function is going to be, all right, 0.75x plus 4.5. Now part B is saying what is the slope and the y-intercept of f of x meaning in this given situation. So what we must remember is that the cost of creating the greeting cards are going to be 75 cents for every greeting card. But we also had an upfront cost of $4.50. So what that means is in our calculator, if we go to our table, before one single greeting card is produced, so when we have 0 greeting cards, we still have that expense of $4.50. All right, pause the video and let's look at our next question.